Hello everyone, my name is Timothy Lee Grant. Today we are going to be going through a problem here on Leetcode. So I've been trying to work on trees. We're going to see if we can solve a tree problem. So let me minimize myself there. What would be a good one? Let's see. So we're going to do a medium. And what's the next one here? Construct binary tree from Inorder. Let's try it. Let's see if we can get it. Okay. All right. Ready? Number 106. Construct binary tree from Inorder and Postorder traversal. So, thinking through it, okay, what is Inorder? That is, we go to the right, go left, then process, then right. So it's in the middle, right? Then, Postorder is we go left, then we go right, and then we process. So that's kind of what we are. Oh no, was this the one that? Oh, I've attempted this problem, haven't I? I've already attempted this problem, and I hated this problem so much. Okay, so trying to remember. Darn. Okay. Oh, I shouldn't have clicked on this one. I don't want to face this problem. Okay, so given two integer arrays Inorder and Postorder, where Inorder is the Inorder traversal of a binary tree and Postorder is Postorder. So we're given the Inorder traversal and we're given the Postorder traversal, and our job is construct a tree from that. Okay, so the idea, I remember kind of what the idea was. The Inorder gives you some information about the tree. Postorder also gives you some information about the tree, and it was something along the lines of where it splits, right? So if I'm thinking about this, Inorder tells me where it splits, right? So I'm just gonna go through this. So Inorder, I don't process this. I don't process this. I come down here. I go left. Then I try to go left again, but I can't. So then I process this. Okay. Then I try to go right, but I can't. So then I come back up here. Okay. And I already processed this. So then I come up here. Hold on a second. Was the problem that I did Postorder? I thought it was pre-order. Maybe I didn't do this problem. Okay, so let me keep thinking through this. So I processed this one, and then I processed this one. So it's 9 and 3 for Inorder, right? 9, 3, and then come here to 15, process it, then 20, then 7, right there, right? 27, yeah. So what information does this problem give? That's the question. Okay. This gives the leftmost. This gives the leftmost as well, or then this one's the second most left. Leftmost. So it's kind of like in this order, kind of like a sliding order. Okay, that's Inorder. Postorder is here. So I have the 9. Okay, this has to be a different problem because I remember distinctly the other one, it would always give you the head. And that is pre-order, right? So in this one, you always have pre-order here. So you process it and you know, oh, there's my head, right? And then based off that, you can look at where it's like splitting And this one kind of shows where it splits, right? Like if I have 3 here, I know everything to the left of 3 is to the left of this physical node. Okay. So that's how you did it in the past. So now, what information does Postorder give me? 9, then 15. Oh no, what do 9 and 15 have in common? So I see 9 and 15 are here, okay? And I have a 3 in the middle, so that's my head. I'm trying to find head. Nine and 15 are here. Okay, does that help me? Let's see, 7, 9 and 15. There. 7 and 20. 7 and... It doesn't help me. Where is 20 in relation to 15 and 7? So 20 is the head of 15 and 7. Okay. Fifteen and 7 are here. 9 and 15. 9, 15, head is 3. Okay. Now can I go 7 and 20 here? 7, no. 9 and 15. And there's 2 nodes in between this 9 and 15. So 3 and 20. Where are 3 and 20? 3 and 20 are there. I can't see any pattern at all. All right, so now I'm trying to think about what went wrong. Do I have like a bad understanding of pre-order, post-order, in-order, traversal? Maybe I don't understand what information post-order gives. Like, so post-order is I'm processing at the end, so there's no children, right? So 9 has no children. Now, "15 has no children." Okay, so I've already processed it. Then I come up here, 7 has no children, then 20 has no remaining children. And then 3 has no remaining children. Is there some way that I could flip? If, because if I did it pre-order, that's what I'm thinking. If I did a pre-order and pre-order gave me the head, okay, and now I'm seeing here 3 is at the end. That's kind of interesting. Maybe maybe pre-order and post-order are the exact opposite. and I can look towards the end to see where the head is. So I see this 3, and that's where the head is. Okay. Then I look here, and I process everything. I know that the head is at the last index. Okay. So then I can come here and get all of the values right here. Okay, so it's just 9. 9 is there up until I reach this 3, the head. Then I have 20, which is the right child's head. So 20 is here. And then I look 20, and then 15 and 7, so this is where it breaks, right? I'm going to try to start typing something and see if I get inspired. Def traverse, okay, and then node, okay, and then I need some pointer, so I'm gonna try to get pointer 1 is equal to this Inorder, and I want to start, I don't know where I want to start yet. Pointer 2 is going to be at the end of the post order. So length of post order. And now do I want length of the post order or length of post order plus 1? Or minus 1. What do I want? So length gives the number of elements. I don't want the number of elements. I want the index. So it's going to be minus 1. Okay, so that's at the end. So it will point to this 3. So that's going to be the node. So now I can come in here and do like, we need a base case. So base case, it's going to be something. We don't know. I don't know. But then I'm going to have create node. Okay. And so now I'm going to have tree node. What is it going to be? I don't know. I passed in a node there. Do I want to create the node here, right? Maybe I don't use recursion though. The other one I used like a while loop. So while, and I'm just going to go backwards, right? So while pointer 2 is greater than or equal to 0, then we're going to do something. Okay. What are we going to do? We're going to create a node out of this where we currently are pointing. So I want to create a node, tree node, right? And then I pass in what? Value left and right, okay? So value is going to be pointer 2. That's the index, and I'm going to go to post order, okay? Indexed at pointer 2. That's going to be the value. It's the 3 right there, okay? And then so far I want no left or right child, okay? So now what I want to do is I want to do another while loop. So while pointer 1 I need to go through here and find when it's the value, and I forgot how to look that up. Because I need to go here and then oh, come on. All right, so what I think I'm going to do is go and look at the old problem. I'm going to go look at the old problem and see, it actually even might even be here. Here it is. I'm going to see how I solved it in the old problem and see if I can figure out some, so now we're given the pre-order and the in order, okay? Value equals pre-order. Okay, so we are using recursion. And we're indexing the arrays. Okay. So let me just put this over here. So that's going to be my hint. The in order and the post order are like my arrays, okay? So now I'm here, I need to create something, right? Like this is my recursion. I'm going to call myself here. So I need this. If this is recursion, then what do we need? We need a base case. So what is going to be the base case? So if not, and then do we want in order or post order? Well, post order is actually going to be the one coming down. So if not post order, then return none. Okay. Now, what we do have a post order. So I want to create this node, right? So the post order is going to be at the last index because that's all, the way that I'm going to construct it. The post order last index is always going to have the node. Okay. So how am I going to do that? I'm just going to say node. Actually, I can just call it root actually because it's going to be the root of my subtree. And like this, I'm going to pass in 20, 15, 7. So I'm going to pass in this one, and now so this will be what I pass in as my left child, and then this will be the index on the right the left, and then 20 will be there. Okay, so root is equal to tree node, and then what do I need to call? I need to index in order. So how does indexing in order work? No, sorry. I don't need to do that. I'm just creating a node right now. So the value is going to be post order indexed at the last element, so -1. So that's going to be the value. Okay, so now I'm going to create root.left is going to be equal to something. Root.right is going to be equal to something else. Okay, and I'm going to build them through tree and then indexing the pre and post order, or in and post order. So build tree like this, and now I need to think about, okay, well, how am I going to do this in order? In order is where it breaks. So I want the left here. So I only want this one here, right? No, this post order. When I started reading through this problem, I just started getting flashbacks because I worked so hard on this one and it was so difficult for me to get it. And now I haven't looked at this one in like whatever 2 or 3 weeks, and now it's back and I'm like, the same concept but different, and I'm like, it's also something that I'm thinking about is, okay, well, is there a problem in my studying that I'm not able to generalize, right? If I've seen this problem essentially before, I'm not able to generalize it. Or maybe I didn't understand this one as much as I should have. So I want to build the left tree, and I need to pass in the in order and the post order. Do I need to loop through and find this middle point? Okay, I'm going to look back up here. Index, yeah, so... Okay, so I do need to get that. So... index is equal to, and then this in order, index of what, and I want that value, the root node's value. So this is going to give me 1 right here because it's the index here. Okay. And I know that I need to do that to build my, okay, so in order, indexed at something, and then post order, indexed at something. My left. What is my left? Here. And I want to pass in for in order. It's everything to the left of my where it breaks, right? Because this shows me where it breaks. So, and I don't want to include the root itself. So this is going to be from the beginning to the index. And index is not included because I don't want that 3 there. So it's only going to be that 9. And then for post order, I want should I pass in this entire thing? No, because it's only that 9. So I'm not sure what this one is going to do. Well, I guess I can, post order. What does this teach me? I don't know. Okay, so on the right, I'm just gonna look at the right now. I don't know about this one. So on the right, I'm going to pass in this as my post order. Okay, so post order is going to be from 0 all the way to the end, but I don't want to include the end. Is this non-inclusive? I don't even know, man. Length of post order, and that's the number of elements, so I -1. Oh my gosh, I don't know what I'm doing. So now in order comes here, and now I want to pass in this here. So I have this 3 as my head, or as my root, and that's where index is, and I want to pass in all this. So it's index not index not included, so index +1 all the way to the end. Okay, and now post order. Oh, what do I want? Post order is going to be here. And on the left, man. It's only that 1, but so I can't put in the entire thing because it's not there. Wait, no, sorry, here. Wait, yes, no, here. So this one, I'm at 3, and I'm trying to figure out how do I. I did all of this excluding the last one. But now if I do that again here in my in order, or sorry, here, and just do this again, next time I go in, it's going to be this 9. But I'm actually going to create this 20. All right, I'm gonna have to look at the solutions. I can't think of a. Okay, well, that's why you don't use C++. Okay, so this one has Python. Good. Okay. See, much nicer. So we find the post index. They're traversing. They use a while loop within. Did I use a while loop in here? No, I didn't. So does this seem like a different type of solution? But they're doing this left and right. Wait, no, sorry. This is the base case. They create the node. They decrease where the index is. All right, well, I think this one is going to be another problem that I have to contemplate for a little while to try to understand it more. I mean, on one hand, it's good that I was confronted with this one because it means that, okay, well, obviously I didn't understand this one as good as I want, and now I can do both of these problems kind of together and try to compare and contrast them and understand a lot more about what each of these traversals actually means. So, all right, going forward, I will continue on this problem, this 106, and try to get it. So that's how I'm going to be moving forward. If that is interesting to you, subscribe to this channel. Hopefully one day I will be able to actually start becoming competent at Leetcode. It's been a year now, and I don't know. I don't know. So yeah. But anyways, hopefully one day I will be competent at Leetcode. And if that is interesting, subscribe. Hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and goodbye.